So in this video, we're going to talk about a certain situation where the sine power is odd. Okay, so we're talking about integrals where we have a sine power that's odd. So an example here would be like the integral of sine to the fifth x cosine cubed x dx. Now we don't care about the cosine. We're just saying when the sine power is odd, and see we have x to the fifth, so the power is 5, that's odd. So that's this scenario here. So what do? We strip off one sign and make it the du after writing everything else in terms of cosine, okay? So what does that mean? So if sine is your du, okay, then cosine is your u, all right? So we're writing everything else in terms of cosine once we strip off one sign. So let's strip off one sign, see what we get. So this becomes, well, if I strip one sign away, that becomes sine to the fourth x times sine x, right? So I'm going to take the sine to the fourth x and put it front here. And then I've got my regular cosine cubed x here. But then I'll also have my other sine x that I stripped off, and I put that with my dx at the end, okay? So I've stripped off one of the signs away from my sine to the fifth x, and I put it over to the side with my dx. That's going to be my differential. Now, if that's my differential, then I got to be thinking, all right, what gives me a derivative of sine? Well, cosine does, right? So it's off by negative multiple, but that's easy to fix. So now, once I strip off my one sign, and I make that my du after writing everything in terms of cosine. So right now, this is in terms of cosine, but this is not in terms of cosine. What do we need to do here? We need to fall back on our identities. What do we know about identities? Well, we know that sine squared x plus cosine squared x equals 1. Well, that's great. What about sine to the fourth, right? That's what we're trying to get rid of. Well, we know that sine squared x squared is sine to the fourth, okay? So we're going to solve this equation for sine squared. So sine squared x equals 1 minus cosine squared x. And to get sine to the fourth, I'm going to square both sides. All right? So I'm going to replace this with that right there to write everything in terms of cosine. So now I have 1 minus cosine squared x squared cosine cubed x sine x dx. Okay, and you might be thinking, Mr. Clark, you just made a problem that was kind of hard into something that was a booger, right? So maybe you're thinking that. Let me show you why it's actually not as bad. Remember when we talked about this du thing going on here? I'm going to make a substitution now. So I have everything in terms of cosine. So I'm going to say u equals cosine x. Then that means du is equal to what? Negative sine x dx. All right? So how am I going to handle this? I'm going to replace every cosine with a u. So this becomes integral 1 minus u squared, parentheses, that quantity is squared. And then I have, well, once again, if I cube u, I get cosine cubed x. So you see that's u cubed. All right. And then I'm left with sine x dx. Well, what's the problem? I have sine x dx, which is positive here, but I have a negative here. So how do I take care of that? I divide both sides by negative 1. So negative du equals sine x dx. So I'm going to replace this with a negative du here. And so I'm going to simplify. Okay, when I do that, I pull the negative outside here for my du. Now, multiplication, we got to multiply this out. I suggest you write it out. If you want to do it in your head, great. If you're able to do that, if you can't, you want to be sure like me, write it out. When in doubt and you're squaring, write it out. All right, double distribute, or FOIL as they say in college algebra. So 1 times 1 is 1. 1 times negative u squared, negative u squared. Negative u squared times 1 is negative u squared, and negative u squared times negative u squared is positive u to the 4th. So in parentheses here, I have 1 minus 2u squared plus u to the 4th, all multiplied by u cubed du. This can simplify if I distribute the u cubed to each piece in here. I have what? U cubed minus 2u to the 5th. Remember, whenever I multiply things same base, I add the exponents. U squared times u cubed. If you think about it, that's like u times u for u squared, and then u. And then that's 5 u's. That's how we get to that 5th. We add the exponents. Just a little quick review for you if you needed it. All right, and then the last one here, this is u to the 4th times u to the 3rd, which is u to the 7th. Add the exponents. So now I'm going to integrate this. And when I integrate this, I'm going to integral add 1 to the exponent of 3. I get u to the 4th over 4. The negative distributes through. And then negative, negative make a positive for the next part. So that's u to the 6 over 6. And then we have u to the 8th over 8 plus c. This 2 and 6 will simplify. And I'm going to replace u with, well, what was u equal to? It was equal to cosine x. Remember, my answer needs to be in terms of the variable we started with. We started in x, we're going to end in x. So this is good, but it's not good enough. Substitute u to the 4th, that's cosine to the 4th x over 4, and then plus cosine to the 6x over 3. Remember, the 2 and the 6 canceled there. And then minus cosine to the 8x over 8 plus c right there. Okay, that's a funky looking c there, but that is cosine to the 8th over 8. So this right here, pretty weird looking right there. That is the integral of this function that we started with right here. So the trick here, if you see an odd power of sine, you look here and you say, okay, that's a 5th power. I'm going to take one of those signs off, save it to the side here, right? And then I'm going to rewrite that one that I stripped off. What's left, I want to rewrite it in terms of the cosine. Now, why am I doing this? Well, you think about it. If I have an even power of sine, then I can use this trick of the trigonometric identities, right? No matter if this is sine squared, sine to the 4th, sine to the 6th, sine to the 8th. You know, what would you do if it was sine to the 6th x? Well, instead of sine squared squared, it would be sine squared cubed, right? So that's how we work through it, and then it would be cubed here, and then you just imagine cubing instead of just squaring, which that would be not nice. All right, hopefully this helps out. In a second, we'll show you what to do when the cosine power is